Hello, my name is Kara Seaton, and today I will be explaining wave-particle duality, which is a very fundamental principle in quantum physics. Now, quantum physics is the study of how physics works on a very, very small level, like the molecular, atomic, and subatomic levels. It turns out that when you get very, very small, these particles behave very differently than what you would expect from the larger scale that we see all the time. So wave-particle duality is a property of behaving not only as a wave or only as a particle, but as both combined. And quantum systems show this wave-particle duality because they cannot be described as either only behaving like a wave or only like a particle, but only as both. This was first exhibited in the double slit experiment by Thomas Young in 1803. This was first done with light, and it was later repeated with electrons. And in this video, we'll be focusing on the electron version of this experiment. So the way this experiment is set up is that you have an electron beam gun, and it fires electrons at a metal sheet, and then there's a detector screen behind the metal sheet which detects when an electron hits it. And there are two slits in this metal sheet the electrons potentially go through. So what the scientists had predicted was that because electrons are matter and particles, they expected they would behave like particles and either hit the metal sheet or go through and form like two lines of electrons behind where the slits were. That's a relatively reasonable expectation. However, what they actually found was very different and would change science forever. They found what's called the interference pattern. And this is a pattern of bands of light and dark areas like this. And these dark areas would represent where electrons hit the detector screen. And the reason why this is so interesting is that interference patterns are very characteristic of waves. Waves, when they cancel out and come together, they'll either, in certain places they will cancel out, and in certain places they will add together. So if you see right here, here are two interfering waves, and this line represents a crest, and this space in between the lines represents a trough. And so these two waves came together, and places like here where you see these X's are where two crests came together to make even larger crests, and these spaces in between, these diamond-shaped spaces, are where two troughs came together to make an even deeper trough. And then there are other areas where a trough and a crest came together and canceled out. And so you can see that there would be a line of higher energy right here, because that's where they added together, the waves. And there would be another one right here, another one right there. And so if I had a detector screen behind here, you could see that I would have three areas of higher energy. And obviously, as you add more and more layers to these waves, there would be more and more bands. And so this is the first time that it was shown that quantum systems, which is basically just any kind of quantum entity or group of quantum entities, exhibit behaviors of both waves and particles.